So in this section, let's talk about ranking. Now, if we don't have a normal distribution to work from, if our sample data does not come from a population parameter that is normally distributed, we've got to create a distribution somehow. We can't use the normal distribution. We've got to come up with one. And the way that we do it is we rank the values, ranking from lowest to highest in ascending order. Now look at this. Right at the top there, imagine these are our values. We've got 13, 12, 2, 14, 15, 3, and 40. And I can certainly rank them, or at least place them in ascending order. So we start at the smallest value and end up with the largest one. 2, 3, 12, 13, 14, 15, 40. And I can now just simply assign a rank to them. 1, 2, 3, 4, 5, 6, 7. And that 1, 2, 3, 4, 5, 6, 7 is what we're going to work with. We cannot work with the actual data values because they're not normally distributed. We can't use a mean. A mean would not be a proper representation of those values. We are looking at using the median. And because the median is a value for which half of the values will be less than and the other half's more than, it's important for us to know that rank. And it's that rank that we're actually going to work with. Now you might ask yourself, what if there's a tie? I mean, if we're dealing with sample sets of 60, 100 patients in each group, we are going to have, or might at least have some ties. What do we do there? So imagine we have, instead of the first 13, that was a 12. So if we wrote them in order there, it would be 2, 3, 12, 12, 14, 15, and 40. What do we do? What do we do with these ties? And as you can see there, it's actually quite easy. The 2 would be ranked 1, the 3 would be ranked 2, and the two 12s would have had a rank of 3 and 4, but they equal, so you add the 3 and 4, 7 divided by 2 because they're two values, that gives you 3.5. So they each get a rank of 3.5. But remember, they take up 2 positions, so the next one, the 14, actually has to take up rank number 5 because it's 1, 2, 3, 4, 5, and that leaves you with a 3.5, 3.5. So you just add all of them and divide by how many there are. So that will leave you with a 3.5, 3.5, because it was 7 divided by 2. And the next rank, 6 and 7. So ranks are very, very important. It's what we're going to use to do most non-parametric tests. In the next section, I'm just going to use signed ranks. So we're going to combine what we've done up to now.